Okay, so I opened up Visual Studio, our IDE of choice, and we're going to create a new solution here. So we're going to new file, new project, and we're going to start out with a blank solution. So just a solution with no code, no projects, nothing whatsoever in it. And we're going to call it we're going to call it Speedrun WCF or something like that. Name it whatever you want. There we go. So now we have a new completely blank solution, and we're going to add a new project to this solution. So actually what we're going to do is we create multiple projects inside of this solution, so multiple assemblies to basically separate the concerns. So basically we're going to have a project for each layer of the application. You're going to see what I mean in a minute. So we're going to right click here, add new project, and we're going to say it's going to be a class library .NET standard speedrun wcf.data. It's what it's going to be called, and this is the project, or this is going to be the assembly that's going to be it's going to contain the actual data models or the domain models. Call it whatever you want. Create. It's going to take a second because my laptop actually has to handle quite a bit right now. Okay. It will automatically add an empty class into this library, but we're just going to delete that. Okay. Yeah, so basically we now need to create classes for our data model. And since it's very simple, let's see, do we need to divide it into namespaces? I don't think so. No, we're simply going to add them to this project here. So go add class well, actually, let's create a folder here, call it models, and we're going to add a new class, and we're going to call it game. And it needs to be public, otherwise it would be internal and we wouldn't be able to reference it outside of this assembly, which would be pointless. So yeah, there we go. And really our data models are going to be POCO classes, so plain old CLR objects. Some people also call them or refer to them as plain old C# object, which is technically not what this acronym translates to, but that's just as fine. So basically what that means is these classes are going to be very, very simple. All they basically do is encapsulate the data that we want to store and work with. And I'm simply going to add a new property ID, a new property, what was it, name, which is a string. And the next property is going to be of type datetime, or actually nullable datetime. Release date, and by the way, if you're wondering how I'm doing this so quickly, I'm using this code snippet. It's a built-in Visual Studio code snippet. If you just type prop and press tab twice, it's going to automatically stub out this auto property with a public getter and a setter, and all you need to do is specify the type and the identifier. actually, we do need another property, and it's the publisher name, right? So it's going to be a string, and it's called publisher. And that's it. Like I said, it's a very simple class. It's a POCO class, plain old CLR object. This also implies that it does not depend on any framework. Not usually, by definition, a plain old CLR object, which comes from POJO, which means plain old Java object. So this is basically the .NET adaptation of it. By definition, it should not rely or depend on any external framework or something, because then it wouldn't be a plain old object. So yeah, basically it's just a very simple data container. Yeah. And some people say that a POCO class is not supposed to have any behavior, which is actually not true by definition. All it says is it shouldn't depend on any framework or something, shouldn't be technology specific, and it shouldn't be complex. But it doesn't mean that it can't have like one or two methods that do a little bit of stuff, a little bit of logic, a little bit behavior. I don't agree that a POCO class automatically implies that it does not have behavior. That's simply not true. But in our case, they actually will not contain any behavior. It will all be done by the domain services and application services. Okay, so let's go ahead, create another class and call it, hold on, I need to check something. Okay, sorry for that. We're going to create a new class, and it's going to be the player. And it also needs to be public, otherwise it would be completely pointless, because it's in its own assembly, which we specifically defined to, well, contain all of the data models, yeah, to reference them from outside. Okay. Let's go ahead and add an ID. And as you see, okay, this also has an ID, so why not create like a base class, a super class, parent class, whatever you want to refer to it as, that has an ID property and inherit it. But that's already too much complexity, and we wouldn't have any benefit from it, because yeah, it's going to be a very, very simple application. Actually, it's just a web service. Gamer tag. Gamer tage. Okay, and for now that's it. Actually, what I do want to do is override the toString method, just to make the debugging a little bit easier. So I'm just going to type override and tab twice. Override and tab once, and then choose the toString method, and actually make it return. Actually, what I do like to do is implement the toString method like this. And since this is a very short method, we may as well use an expression body, which makes it look like a lambda expression. So this is what I usually do when I override the toString method. I take the most important most essential properties. Use the name of operator to get the name of the property. I may as well just make it say ID colon, but then if I change the name here, it will still say ID, which is not cool. It just means that I have a lot more or a little bit more maintainability effort. So I'm going to use the name of operator instead and rename this back to ID. Yeah, that's what I usually do when I override the toString method, unless there's like a more intuitive, in a specific context, there would be a more intuitive way to override it. But yeah, this is like my go-to implementation. And we're going to do the same thing with the game class. Override toString. If you're not familiar with it, this is the string interpolation operator, and it allows us to basically use these placeholders with the open and close braces and place whatever variable, whatever field, whatever property in there. It's effectively it's the same as just concatenating the strings. There we go. Yeah, I think that's it. And another model for the speedrun. Create a new class, call it speedrun. You actually don't have to type .cs, it's just a habit of mine. Make it public. Give it an ID, give it a, what was it, record date. A time span called time. And it also needs reference to the player, but we may as well model it the other way around, because speaking in an object-oriented context, we would actually say that a player has a speed run, or a player has multiple speed runs. But effectively, the way we want to use this model, I think it's better for us to do it this way, to store a reference to the player in the speed run. We may as well do both. Yeah, okay, that's what we're going to do. So for now we basically model it the same way as we did when we created the table. Oh, sorry, game. There we go. So that's it for our data models for now. Yeah. So now we need to map them to our database. And we're going to do that using the entity framework. Specifically, we're going to use entity framework core, which is basically the .NET Core equivalent of it, meaning that it is cross-platform compatible, and also it's just very lightweight. The entity framework itself is a little bit more powerful, so to speak, but we don't need all that. We're going to use the lightweight version, basically Entity Framework Core, to map our models to the database. Let's create a new project here. Add new project, and it's also going to be a class library, .NET Standard, and we're going to call it Speedrun WCF infrastructure. Speedrun WCF infrastructure. Yeah, I just made sure I didn't misspell that or something. Okay. So yeah, we don't need this class 1. Okay. So now we want to install Entity Framework Core, and we're going to do that using the NuGet package manager. And it's very, very simple. We're just going to right-click the dependencies here and say Manage NuGet Packages. So NuGet is a .NET package manager. So it basically handles the dependencies for us, and we can browse for the latest version of Entity Core and have it downloaded automatically, stuff like that. Entity Core. There it is. Let's actually go with version 3.0 for no particular reason. Hold on. Oh, right. Okay. We chose .NET Standard version 2.0, and this is not compatible with 2.0 or 2.0. So we either need to upgrade the .NET Standard version that we use in both these projects, or we need to use an earlier version of .NET of Entity Core. I don't know. It doesn't really matter because an older version would be just as fine. Yeah, let's just use version 2.2.6. That's fine. See, that's what happens when you do an impromptu tutorial. It's not even really a tutorial. It's just a let's create or something. I don't know. A showcase. This is, yeah. Call it whatever you want. Okay, so now we installed Microsoft Entity Framework Core, and we also need the package Entity Core SQL Server. This is basically an extension that makes it easier to map to map to an MS SQL server database. We're going to also use this older version. It doesn't really matter. Okay. I mean, normally I would always suggest to use the latest version, but in this case, we will be fine using this older version. Okay, so that's done. So now our infrastructure layer has a dependency, a reference to Entity Framework Core. And what we're going to use is a very simple repository pattern. And for that, in our data project, we're going to create a new folder and effectively a new namespace called repositories. And here we will define interfaces. And the first interface we're going to create is will be the iGame repository. It's basically a contract for, well, a repository for storing and retrieving game instances. And this contract, this interface, is going to define the following methods. First of all, we're going to need a method we need to add a using statement here to reference our models namespace. And we're going to have a method that returns an instance of game, and this method will be called getItem. And it takes an integer, a parameter of type integer called ID. So later on, when we implement this interface, we will have a method where we can pass the ID of a game and get the actual game instance returned. Also, there will be a method that returns all of the games in the database. It's called getItems. Then there will be, well, actually, I think this should be it for now. We don't want to be able to add new games or delete games. We don't need that, at least not for now. Let's create another interface. And I will get into why we create these repository interfaces. I will get into that in a minute. Let's just go ahead and create the IPlayer repository interface. It's also going to be public. And basically, we want this to do pretty much the same. If I just type player, you will see that IntelliSense Visual Studio won't recognize it. That's because it's in a different namespace. We can either go here and add the using directive ourselves, be like, what's it called? Speedrun something, data models. Or we could just right click the curly, the underlined thingy and go and have IntelliSense do that for us. Get item. And of course, we could do this more generically. We may as well create one generic repository interface with a type parameter. But for sake of simplicity, we're not going to do that. So as you can see, so far it's completely identical with the iGame repository interface. The only thing that's different is the return type of these methods, and we could have also just used a type parameter and have one generic interface instead. But like I said, it's going to be simple, lightweight. We don't care about that. It's not optimal, it's just, you know, for the funsies. And we don't need to add, insert, update, delete a player, at least not for now. So let's go ahead and create another interface for speedruns. Repository, yeah, that's correct. let's go ahead and Speedrun. Let's have IntelliSense handle that for us. There we go. And there we go. That's done. Okay. So the reason that we created all of these repository interface is, first of all, that we can, if we want, we're probably not going to do that, but if we want, we can swap out the concrete implementation of the repository later on. So we could now create one implementation of this repository that actually interacts with the database, and then later on we could, for testing purposes, have another implementation that just returns mock data, mock-up data. So just testing data that is not actually retrieved from a database, but it's just created on the fly, or like read from a file or something like that. So we can basically have the freedom to swap out the implementation. And also, we don't want our service layer to know about the infrastructure. Our service layer doesn't care how the data is going to be persisted. It just needs to know. It just needs to have a way to retrieve the items and write them into the database, but it doesn't need to know how that's actually done. So yeah, as we proceed, you may get a better understanding of what I mean by that and why that is. Let's go ahead and use entity to map our data model classes to the database tables. And for that, we're going to go into our infrastructure project. And here we're going to create a folder first. And I'm just going to call it config for configuration. And here, I'm going to create a new class. I'm going to call it Speedrun DatabaseContext. And this class needs to inherit from a class from the entity framework core, and it's called DB-Context. And it's in a different namespace, that's why it's not recognized at first. It's in the Microsoft Entity Framework Core namespace. And there we go. So now that we have this class that inherits from DB-Context, we can use this class to configure our data model and our database mapping. And we do that by simply overriding a specific method, which is called onConfiguring. And here, this method has a argument options builder, and we can use this options builder to configure our database configuration. And this is going to be very simple. We're just going to say use SQL Server, which is an extension method that we installed with the with this Microsoft Entity Framework Core SQL Server package. And here we're going to simply pass the connection string. So the string that defines the connection to our database. And And there's multiple ways to get this connection string. One way would be to use the Server Explorer in Visual Studio. You can just go to View, Server Explorer, and this will show up. And then you go to Data Connections, Add Connection, select Microsoft SQL Server, continue, and the server name in this case is LocalDB, MS SQL LocalDB, because I'm using, well, the LocalDB. Click refresh, make it load the available databases, and it should appear here in this list. There we go, Speedrun Database. Okay. There we go. And now down here in the properties window, there should be, there it is, connection string. And we can just copy it and put it here. And that's it. Actually, it would be better to put this connection string in like a configuration file and read it out at runtime. But in this simple example, we're just going to basically hard code it here. So yeah, that's fine. Yeah, it says unrecognized escape sequence because we're actually using the escape backslash character here, and then yeah, basically escaping the M, which doesn't make sense. So we're just going to make this a verbatim string. The other way to solve this would be to just add another backslash. Same thing. Okay, so now we have the connection set up, and now we need to set up our models and to the mapping to the database tables. And we do that by simply overriding the onModelCreating method. We can remove the call to the base class implementation of the method, and instead use the model builder that is passed to the method to configure our models. And the model builder has a method called entity, which has a type parameter, and here we can pass the type of the model that we want to configure, which would be a game, which is in a different namespace. Actually, it's in a whole nother assembly, so we need to add a reference to that assembly, to that other project. We can either do that using IntelliSense and just go here, quick actions, add reference to, or we can explicitly go here, dependencies, add reference, and then select the other project. There we go, and now it should know about game, but it's still in a different namespace. So we're going to have to use a using directive. Okay. And this will return an entity type builder. We're going to store that in a local variable. Make it say game entity. And now we can configure this more specifically. We can map it to a table. The table, I think, was also just called game. We can make it say, we can make, what are you doing? There we go. We can configure the primary key via the has key method. And here we have multiple possibilities. We can either just say, pass it as a string and say that the ID property actually represents the primary key, or we can use a lambda expression, basically pass a function that returns the property that we want to map the primary key to. And now we need to map all the other properties. And we do that using the property method, and also we can also pass a lambda expression here and have it return the ID actually. And then there's the hasColumnName method, which we use to map this property to a specific column in the table game, which would be actually also called ID. And in fact, if the column has the exact same name than the property in the class, we don't actually explicitly have to call this method. Entity would just assume that the name is identical, but I like to actually specifically configure this, but in fact you don't have to. Let's do that for all of the properties. So as I said, there's multiple overloads of the property method. You don't have to use the one that takes a delegate if you're not comfortable with lambda expressions or anonymous methods. You can also just make it say publisher as a string. That's just as fine. I usually use lambda expressions for that. Okay, so now we did map it to the table. We also set up the primary key, and we mapped all of the properties to appropriate columns in the table. And I think that's it. Did I forget something? No, that should be it. So now we have mapped our game class to the game table in the database, and we also configured how the database context is going to actually connect to the database. Okay, so that's it for our game model. We also need to do that for the other models, but I think we're first going to actually test this. And in order to test this, we're first going to implement our game repository. So we're going to, hold on, excuse me. We're going to add a new folder here in our infrastructure project, and we're going to call it repositories. And here we're going to create a new class called game repository, which is public, and it implements the iGame repository interface, which is in a different namespace, even in an entirely different assembly, but we're going to add a using directive via IntelliSense and include it. And now the compiler is going to say that, hey, your class does not actually implement this interface. We can now manually implement it. Game is also in a different namespace. There we go. We can either manually implement all of the methods now, or use IntelliSense quick actions and select implement interface, and it will automatically stub out the implementations for all of the methods in the interface. And now we just need to actually implement them. And in order for us to implement them and actually get the game out of the freaking database, we need the database context, an instance of the database context class that we just created. So we're going to do that by defining a constructor, and there's a shortcut for that called ctor, and you just hit tab twice and it will create a default constructor. And to that constructor, we're going to pass the Speedrun DatabaseContext, which is in a different namespace. That's why it's not recognized. This time I'm going to do it manually for funsies. There we go. It's called the parameter context. And we're going to have a field which will be read-only because it will never change once the repository is instantiated. Private read-only Speedrun DatabaseContext. We're going to call it context. And then in the constructor actually initialize that field. Okay, so now we have the context to use in order to work with the database. And now in our getItem method, we're simply going to use this context in order to retrieve the game instance from the database. And there's multiple ways to do that. One would be to simply use the set method, and it has a type parameter. It's a generic method that has a type parameter where you pass the type of the entity that you would like to retrieve. And this returns a queryable collection of all of the game instances in this database, but we only want this specific one with the ID that is passed to the methods. So we can use the find method and pass the ID. And remember, we configured the ID property of the game to be the primary key. So if we actually pass the primary key here, entity will know that this is will actually match this ID that is passed here to the primary key in the database, and on that basis return the instance from the database. And we just want to return what find returned to us, and that's it. And it's such a simple method that we can actually use an expression body, I think. There we go. As I said, there's multiple ways to do that. We could also just use link to get the specific instance by simply calling the, we need to include link. And using link, which stands for language integrated queries, in case you didn't know that, we can use the extension method first or default and pass a lambda expression to it that matches or that compares the ID of the element to the ID that is passed to the method, and this does the exact same thing. So this is also a way that you can do this, but using the find method is a little bit simpler, and it's just fine. It does the exact same thing. Okay, so now we want to have implement this method that returns all of the game instances in the database. And one could argue that we would just return, that we could just return the set of games directly, which would actually work, but we're not going to do that because the set actually returns a queryable collection, which means that, as you can see, it has a lot of methods that are database related. We can actually, if we were to use the where extension method here and pass it a predicate, I don't know, ID is less than 47, something like that. This expression would actually be translated into SQL, and we don't want the returned enumeration of games to still be queryable and to still hold a reference to any queries or the database. And so we just want to return an actual collection of games. So what we can do is call the toList method, which will simply convert this enumeration of games, this queryable collection, into a regular old generic list. Also, we could call the toArray method, which would effectively be the same, since all we want to do is return any sort of enumerable collection. Yeah, it's effectively the same in this case. So let's just call it toList. It's perfectly fine. Yeah, so that's our implementation of the game repository. And now we're going to use that in a unit test in order for us to check if this actually works. We might have actually forgotten something, or yeah, screwed up at some point. I hope we didn't, but let's see.